Hi guys, a very warm welcome. And in this video, we are going to understand about an important service of AWS, that is the IAM. What are IAM or the IAM components? Let's look into it. Objectives. In this module, you are going to understand about work with IAM service, manage IAM components, recognize the best practices of IAM, and manage the keys using the key management service. IAM stands for Identity and Access Management. It's a global AWS service where it is not dependent on the region. IAM is an AWS service which seed the permissions in order to allocate right resources to right persons at right time. So generally IAM is primarily used for providing the credentials to the users who are going to work on someone else's AWS account. And also, apart from just adding up the users, there are a lot of other functionalities that IAM offers. So IAM allows access to compute, storage, database, and application services. IAM primarily deal with four terms, that are users. Users are those who are going to log in into the AWS account. Groups, it is the group of multiple users. Roles, that are related to the services of AWS. And policies, which are related to the permissions, the type of permissions that are granted. The IAM also control both centralized and fine-grained API resources plus AWS Management Console. The IAM creates and manages AWS resources and groups. Also, it provides permissions to allow and deny the access of the AWS resources. So this is a symbol representation of the AWS IAM service. What are the main components of IAM? Let's look into it details. The IAM users. IAM user is an individual who has a set of permissions. For example, if I create your user credentials on my AWS account, you become an IAM user. You're going to log in on my AWS account using your user credentials. Now, what type of permissions, policies I have granted to your user ID depends on the policies that are attached to that user. Okay. So in a nutshell, IAM user is the person who is going to log in on someone else's AWS account. IAM groups. It is the collection of IAM users. For example, IAM user is a single entity. It's a user who is going to work on the AWS account. IAM group is the collection of the users. So let's say on a particular AWS account, I have to add 100 users and I have to give the same permissions to all the 100 users. So instead of manually assigning the permission to each and every individual user, what I can do is I can create a group, attach the permissions to the group. Let's say I give an admin access to the group, and whosoever has been added in that group, the users that are added in that group automatically gets the admin privileges, the permissions. So IAM groups are the collection of IAM users. All the IAM user in a group can access the permissions assigned to the group. So it depends what type of permissions that are being allocated to the group. And if the IAM user is part of that group, would have those privileges as well. Managing users with IAM. So here you can see, this is a diagram. It shows we can manage the users in IAM using some external directory also. Here, using IAM, you can list the users in an account, users in a group, and also the groups to which particular user belongs. So there are multiple ways you can add the users or manage the IAM users. You can add the user directly to the IAM. You can add the users in the group also. And the other way is you can integrate the Active Directory. If you have any external directory of the user details, you can integrate it with the IAM also, and from there itself you can manage the login credentials. Apart from that, the users can also be updated from AWS command line interface. So it is not necessary that you have to create the user from the AWS management console only. You can log in into the AWS CLI and you can create the user from the CLI as well. For example, if you want to change the name from Bob to Robert, then you can do it using update user, username Bob, new user name Robert. So this is basically a command that you can put in the AWS CLI to make the changes. So how to work on the AWS CLI, you can refer the other section. I have already updated that how the AWS CLI works. In AWS account, with the help of IAM, you can delete any user also, or you can disable the user access to resources for a particular time period as well. So let's say I want to block a user for a particular duration, let's say for 1 month or for 2 weeks. I can specify that from the IAM. Even I can do this task from the AWS CLI also. So an example could be, in an organization, if anyone quits or if some user is out for a particular period, then using IAM you can either delete the user access or disable the user access. So let's say someone has gone for a vacation, they are not going to log in into the AWS console or no longer going to work on the AWS. So in order to prevent your AWS account or secure your AWS account, you can disable that user for the duration that person is out for vacation. This is one of the example. Likewise, you can get so many examples when you work on the AWS IAM service. Security management in AWS IAM. So here in the demo, in the lab scenario, I'm going to create a new user. I will provide the credentials to the user like the password and all, the username. And then we are going to test how we can log into the AWS console using the user credentials. So till now, whatever the lab demos that I have done, I logged in into the AWS account using my own credentials, the root credentials, the owner credentials. But now in this demo, I'm going to add or create a new user as a delegate, and that user is going to log in on my AWS account with the help of the IAM credentials. So these are the steps that you can follow from the slide, and I would be doing this demo in the next video, in the lab video. Managing permission with the groups. Why should we manage permission with the groups? There are many reasons for that. So we know that the user is IAM user account provides one login with its own specified permission. So let's say if I create a user, that user would have the set of permissions allocated. But when we create a group, we allow multiple users having the same set of permissions. So it is important for us to manage the permissions with the group so that accordingly the users that are added in the group gets the credentials. So in the big organizations where there are 100 of employees that are going to basically work on the AWS account of the organization, the group creation is a beneficial way of creating the credentials. So this way what happens, let's say if an employee leaves the organization, a new one joins, so it becomes easier for the admin to create the credentials and provide the access to them as well. So primarily when we work on the IAM, these are the 4 main components that we need to look into. User, we have discussed. Groups, we have discussed. Role, roles are primarily related to the services. They are service specific. So the role provides a simple way to delegate group of permission to specific users or AWS services. So generally roles are primarily used for AWS services. I can take one example. Let's say we know what exactly the EC2 is. It's a compute service. S3 is a storage service. Both are different. Now there is a requirement, like if someone logs in into the EC2 instance and wants to access the S3, how that can be done? Can that be done directly? No. So if you try to access the S3 from within the EC2 instance, primarily a Linux operating system EC2 instance, you won't be able to access the S3 and the buckets. But when you create a role and assign that role to the specific EC2 instance, giving the EC2 instance the permissions to access the S3 service, then you can access all the buckets in the S3. Depends on what type of permissions have been granted to the role. So what we understood from this example, the roles are service specific, where EC2 is a service that needs an access of an S3. There is no user involved in between. This is one of the examples, so we'll discuss about the roles in detail. And then we have the permissions. Permissions are the set of policies. So the permissions, it contains permissions which specify which action an entity can perform and on which resource that action needs to be performed. So how to manage permissions with the groups? You can attach a policy to the group, manage group membership to assign permission, restrict privileged access further with the conditions. What you can do, you can create a permissions and you can customize those permissions and assign that to the group. Control access to specific resources using a resource-based policy. Create groups that relate to a job function, a specific job function. Groups you can create. Use manage policies to logically manage permissions as necessary. Regularly check access advisor to restrict access. So when we assign the policies, the permissions to the groups, it is not necessary that I need to assign a single policy to the group. I can attach multiple policies to the group. I can customize a policy. I can create my own permissions and attach it to the group. Even I can restrict the count of the permissions that can be allocated or attached to a group as well. Now in this demo, I will be creating a role for an application that will be running on the EC2 instance so that it can access the S3 bucket or the service. And this way we will be able to understand the functionality of the IAM role as well. You can look into the steps here and in this particular slide, and the entire demo you can watch it in the next video. Coming to the IAM policies. What is an IAM policy? IAM policy is JSON formatted document. Mostly the IAM policies are written in JSON. You would find the IAM policies already defined by the AWS. It comes with the AWS account. There are so many policies that are automatically provided by the AWS when the account is created. And you would have that yellow cube. I'll show you that in the lab demo. However, in case if you want to create your custom policy for a specific job functionality, you can create your own policy, you can write your own policy, but that has to be written in the JSON format. So an IAM policy also defines AWS permissions. It can be attached to a user or it can be attached to a group as well. These are some of the elements of the IAM policy, how the IAM policies are written. You would have a version. Version specifies the current version of the policy language. You will have an action. Action describes the specific action or action that will be allowed or denied. Let's say I want the EC2 instance access, so I will allow it. I want to deny the EC2 instance access, I would deny it. So this is an action. Statement. It contains array of elements. So statements contains array of elements. Resources specifies the object or objects that the statement covers. Effect is whether the statement will result in an allow or an explicit deny. What action we want to take with that statement, with that resource. Effect is, and the principal is, principal element specifies actual identity. So we look into one of the policy and we'll be able to understand it in a better way. This is the sample policy in the JSON format. Version is there, statement is there, effect is allow, action is S3 list bucket, resource the name of the bucket. So what action is? Allow to read all the S3 buckets. That is what this policy is. So if I create a role out of this policy and attach it to the EC2 instance, then I can access all the S3 buckets in my AWS account from within EC2 instance. So I can log in into the EC2 instance, specifically the Linux one, and from there I can type the command AWS S3 list or ls, and it will display all the S3 buckets once this policy is attached to the role, and then the role is assigned to the instance itself. We'll see the policy writing in more detail in the lab scenarios. So in this demo, I'll be creating a policy for a new user to have all admin or limited privileges, and this will be a custom policy, and then we are going to test this scenario. You can see these demo steps. Now what are the best practices for IAM? IAM, as by now you got an understanding that it is primarily used for the user credential and also security for your AWS account. So we need to follow some best practices. So AWS IAM is a service through which we can delegate the access to multiple users. So from here we can provide the access and the permission management we can do. We can do the auditing also. So I can, from the IAM, I can check who has logged in onto the AWS account, what was the last duration, when the login happened. All those things from the audit perspective, I can view it from the IAM. Identity and credential management. So in the case of an identity and a credential management, this is one of the best practices. It is good habit to create an individual user. What are the benefits? You get unique set of credentials. You can assign the individual permissions. What type of a permission you want to grant to a user, you can specify that. Granular control, more granular control. Easy to remove the access. You will just remove the permission and then remove the user. That's it. How to do it? You just have to create a IAM user for yourself and then assign some policies, or you can create a custom policy and assign to that user. Then the next thing as a best practice is always configure a strong password policy. Ensure your user and data are protected. This way, easy to enforce password complexity requirements, and that increase account resilience against brute force login attempts. If your password is simple, easy, then it is easier to crack also. How to do it? You can set up the password expiration after 90 days. So let's say today you create a password. After 90 days, the password should be expired. You should create a complex password and try to do a password rotation. Identity and credential management, enabling credential rotation for IAM user. So the root account holder as well as IAM user in the account should regularly change their password and access keys to analyze if a password or access key is compromised without owner knowledge. So guys, what happens is when you create a user credentials, On the AWS Web Console or on the AWS Management Console, the user ID and the password is required. But if you have to log in as a user on the AWS CLI, the command line interface, or the SDK, the software development kits, then you require the access key and the secret access keys, which can be generated by the AWS from the AWS account. How the access keys works, you can refer the CLI video, how to log in and work on the CLI. So make sure that the access keys are stored in a safer place, and the password that you create should be the complex one. And for that, you can set some password policies and determine the duration of credential validity to use resources. Apart from that, if you want to add further security to your user credentials, so there is an option called two-factor authentication or a multi-factor authentication, MFA. You can enable the MFA service on a particular user, and when the user tries to log in on your AWS account with the password, there will be an MFA code that will be required. So if an MFA device is associated with your user credentials, it could be an application, it could be a key, it could be a hardware token also. Whatever the MFA that you associate, you need to provide the token ID in the MFA tab. And this way you can enable the MFA for the privilege customers. What are the benefits? Enable MFA for privilege user benefits provide an extra layer of protection. For example, mostly in the finance projects, in the banking projects, they look for the users with more secure login connections. So MFA could be a good fit for that. It increases the security for console and programmatic access as well. How to do it? You just have to enable the MFA for your root account. You can use a virtual MFA application, you can use a hardware or SMS MFA, and that will protect sensitive actions with the MFA. We'll see how we can implement the MFA. So in this demo, I'll also show you how we can log in on the AWS console with the help of the multi-factor authentication credentials. These are the steps that you need to follow. Now the next task is access permission to management. Access and permission management. What you should do? This is also one of the best practices. You should grant least privileges. This reduces the chance of more people committing the mistakes and provide a good granular control. So it should not be like if you're creating a user, you just assign the admin access to that user. You should not do that. Whatever type of permissions you want to grant to that user, try to assign that policy itself. Restrict privilege access further with conditions. So it provides additional security, hence reduces the chance of accidentally performing privilege actions as well. Manage permissions with groups. It is one of the simple and efficient medium to provide access or to deny access to multiple users at a time. And always enable CloudTrail to be aware of API call logs. So CloudTrail is a service on the AWS that helps you to audit in more details, in more depth. From the CloudTrail service, when you enable a CloudTrail service, you can get to know who has logged in, what commands, or what action was taken by that user, at what time that user logged in. Let's say if the user accessed the EC2 instance, terminated the EC2 instance, all those activities will be recorded from the CloudTrail. So that's what it says. As a best practice, you should enable the AWS CloudTrail to be aware of any kind of a API call logs. If anyone is logging from an application, or let's say if you do a social media integration with your AWS console, those call logs will also be reported in the CloudTrail. Delegation and audit as a best practice. Use IAM roles along with Amazon EC2. So it is better to use Amazon. Whenever you use an Amazon EC2, try to use the IAM roles. This provides an easy way to manage access key. It also includes automatic key rotation as well. Also use roles to share the access. By this way, we can avoid sharing our security credentials. And if you avoid sharing your security credentials, there will be less chances of getting your security credentials leaked or hacked. Also, there is no need to store the credentials for longer duration of time. So it is better to use the roles to provide the access. And we know that roles are mostly service specific, and we can access these credentials, we can access console from some APIs, from some apps as well, with the help of the roles. Try to reduce or better remove root use. Root usage or root login should be done by the owner of the AWS account or the organization that owns the AWS account. It should not be given to the users or the administrators. So this majorly prevents the misuse of security credentials. So let's say if I want someone to work on my AWS account, I should not provide that person the root credentials. Instead, I should create an IAM user, give them the permissions, and give my account ID to log in into it. That's the best practice. AWS KMS, the key management service. What is a key management service or system? KMS is a managed encryption service that enables user to easily encrypt user data. So with the key management system, you can manage the encryptions and you can encrypt the data. That makes it more secure. So what you can do with the KMS? You can create key with unique alias and description. It allows you to import your own keys, define which IAM user and roles can manage keys, define which IAM user and roles can use keys to encrypt, decrypt data, disable the enable keys as per the requirement, audit use of keys by inspecting logs in the AWS CloudTrail. So it provides a highly available key storage, management, auditing solution for you to encrypt your data across the AWS services. So in case if you're looking for more security, more enhanced security, it is advisable to use the KMS. So guys, it is not necessary that when you use a KMS, you have to apply it to all the users. You can specify the specific IAM user who should use this keys to encrypt or decrypt data. You can specify the roles also. You can disable or enable the keys anytime. So it is elastic. It gives you the functionality to make the changes on the fly as well. Who can use KMS? Mostly developers who need to encrypt data in their applications. They can use the AWS SDKs, which is software development kits, with AWS KMS support. So AWS SDKs is the way to connect to the AWS, just like CLI, but SDKs are more preferred by the developers as it gives more enhanced functionalities and the development tools as well. For scalable key management infrastructure, IT administrators can use KMS to reduce their licensing cost and operational burden. Anyone who is into the support task, who is managing the IT infrastructure, they can use the KMS, and that would encrypt the data, which would make the IT infrastructure more secure. In case of data security for regulatory or compliance purpose, you can use AWS KMS to verify data encryption across the application where it is used and stored as well. So in the security, cyber security, in the regulatories or compliances purpose, so let's say if there is a compliance of a project, every data should be in the encrypted form, should be secured. There also you can use the KMS. Thanks for watching this video. For the next video, we would be demonstrating the lab scenarios on the IAM.